Imagine a world made of metal. No rock, no ice, just pure metal. Not just any metal, but the kind of metal that makes up the cores of our planets. That's the asteroid Psyche. A mysterious asteroid that orbits the Sun between Mars and Jupiter. It's the largest known metal-rich asteroid in our solar system, and it's about to get a visit from NASA. The Psyche Mission is one of the most exciting space missions of our time. It's a chance to learn about a world that's completely different from any other we know. Imagine soaring over the surface of Psyche, gazing out at a world of pure metal. It's a sight that no human has ever seen before. The Psyche Mission is a chance to explore a world that's truly unique.
Psyche gives us the opportunity to visit a core, the only way that humankind can ever do, and it would be the first metal object that humankind has ever visited.
Hey everyone, I am a space enthusiast like you, and you are watching AstroYonder. Welcome to this video, where we will tell you everything you need to know about NASA's Psyche mission, the first ever exploration of a world made largely of metal.
Isn't that the first question that everyone asks? What does it look like? And so I've been dreaming about this object now for over a decade, and by then it'll be 2 decades I've been dreaming about this object. And then to see what it really looks like, what's more exciting than that?
These are some examples of contradictory narratives about the value of the 16 Psyche asteroid. The contradictory whispers about 16 Psyche's worth. Is it a celestial jackpot or fool's gold? Is it a glittering treasure chest or just another cosmic pebble? Let's explore and find out. Sounds exciting, right? Well, buckle up, because we're about to dive into the details of this amazing mission. So, first things first. What is asteroid Psyche, and why is it so special? Asteroid Psyche is one of the most intriguing targets in the main asteroid belt, a region between Mars and Jupiter where millions of rocky bodies orbit the Sun. Psyche was discovered in 1852 by Italian astronomer Annibale de Gasparis and was named after the Greek goddess of the soul. It is the 16th asteroid to be detected, and it is currently about 551 million kilometers away from Earth approximately.
Psyche is an incredibly exciting mission to study an asteroid that is truly unique.
What is the size, shape, and composition of asteroid Psyche? Psyche is not your typical asteroid. Unlike most asteroids that are made of rock or ice, Psyche is composed mostly of metallic iron and nickel, similar to Earth's core.
Our experience so far in terms of exploring the solar system has been with either rocky or icy bodies. What's particularly interesting about Psyche is we think it's a metallic object. We have a common understanding perhaps of how regular common rocks behave, but metal behave in a very different way.
Scientists think that Psyche is the remnant of a planetesimal that was forming in the early solar system, but was hit by multiple impacts that stripped away its outer layers, leaving behind its exposed core. This makes Psyche a rare opportunity to study the interior of a planetary body that otherwise would be inaccessible.
We don't know a lot about our core. What we've learned about it, we learn indirectly, because we can't go there.
It's too hot, the pressure's too high, our instruments would melt. Can't drill a hole that deep in the Earth or other planets. But turns out, we can study a planetary core out in space because there's this one object called Psyche.
Psyche is also one of the largest and most massive asteroids in the asteroid belt.
It is the only asteroid that we're aware of that is 95% metal or more and is really huge. It's about 200 kilometers across in one axis.
So it's about the size of Massachusetts.
Here are some details of dimensions about the asteroid 16 Psyche. Pause the video and have a look. How much gold is there on 16 Psyche? The amount of gold on 16 Psyche is unknown. However, scientists believe that Psyche is made of iron and nickel, which are often found in association with gold. Therefore, it is possible that there is some gold on Psyche. What kind of mission is Psyche? The Psyche spacecraft is part of NASA's Discovery program. Discovery program missions are relatively low-cost missions that investigate high-priority science questions about our solar system. The Psyche mission was selected in 2017 out of 5 finalists after being proposed by a team led by Lindy Elkins-Tanton from Arizona State University. The Jet Propulsion Laboratory, JPL, in California, is managing the project, and the spacecraft is being built by Maxar Technologies in Colorado.
I think the only thing we know, and that's based on NASA's 50, 60-year experience now, is that it's not going to look like what we think it's going to look like. And it's going to be really interesting, whatever we find.
What are the components and specifications of the Psyche spacecraft? The Psyche spacecraft is a box-shaped structure, about 7.8 feet long, 7.1 feet wide, and 16.1 feet high, not including the solar panels and instruments. With solar panels full stretched, it's a size of a tennis court. It weighs about 2,600 kilograms, 500 to 700 pounds, and has a power output of about 600 watts, which is enough to run a microwave oven. The spacecraft has 3 main components: the propulsion system, the science payload, and the communications system. The propulsion system is responsible for maneuvering the spacecraft in space and keeping it on course.
Solar electric propulsion has been around for quite a while, and it has flown before, but we're continuing to push the boundaries. We're going to have big 5-panel fold-out solar panels that will provide the electricity for the thrusters, which use as propellant the noble gas xenon.
We're using a particular thruster technology, Hall effect thruster technology. They operate 5 times more efficiently than normal rockets, so they use a lot less fuel, and is what allows us to get into orbit around this asteroid. This will be the first time that Hall effect thrusters have flown in deep space.
So, now the payload consists of a couple of imagers, which are cameras that take pictures of Psyche. Also, a gamma ray and neutron spectrometer, which allows us to measure the elemental composition of the surface of Psyche. And then a magnetometer, which will allow us to detect any magnetic field that's left at Psyche. Finally, the communication system consists of the Deep Space Optical Communications (DSOC) module, which uses space lasers. This will be the first time it is being tested. How will the spacecraft reach Psyche? The answer is by using gravity assists from other planets. Gravity assists are maneuvers that use the gravity of a planet to change the speed and direction of a spacecraft without using any fuel. They are like slingshots that fling the spacecraft to its destination. The Psyche mission will use 2 gravity assists, one from Earth and one from Mars, in the spring of 2026. When will the mission launch and arrive at its destination? The mission will launch in October 2023 from Launch Pad 39A at NASA's Kennedy Space Center in Florida aboard a SpaceX Falcon Heavy rocket. If all goes as planned, the spacecraft will arrive at Psyche in August 2029 after a 6-year journey of about 2.2 billion miles, 3.6 billion kilometers, and continue orbiting for at least 26 months performing its science objectives. Here is a complete timeline of Psyche mission. Please have a look. What are the scientific goals and expected discoveries of the mission? Characterize 16. Psyche. The mission aims to study the geology, shape, elemental composition, magnetic field, and mass distribution of the asteroid. Understand planetary formation. By examining 16 Psyche, scientists hope to gain insights into the formation of planets, including Earth. Explore a metal-rich world. The mission will provide humanity's first-ever exploration of a world made largely of metal. Determine if Psyche is a planetary core. Scientists will investigate whether 16 Psyche is a planetary core or unmelted material. Study relative ages of Psyche's surface. The mission aims to determine the relative ages of different regions on the surface of 16 Psyche. Characterize Psyche's topography. The mission will use radio waves to measure the asteroid's gravity and map its surface features, providing insights into its interior structure. Here is a complete details of Psyche orbiting 16 Psyche asteroid. Orbit A for 56 days and 41 orbits, intended for magnetic field measurements, imaging, and mapping. Orbit B for 80 days and 169 orbits, for topography, geological mapping, and magnetic measurements. Then, Orbit C for 100 days and 362 orbits, intended for gravity, topography, and magnetic measurements. And finally, Orbit D for 100 days and 684 orbits, for composition measurements, gravity, mapping, and magnetic measurements. What instruments will it use? The science payload is the heart of the mission. It consists of 4 instruments that will collect data about asteroid Psyche's shape, surface, composition, structure, and magnetic field. The instruments are a multispectral imager.
The cameras on Psyche, we call them the Psyche multispectral imagers. They're a pair of identical cameras. They're a pair for redundancy, just in case we have a problem with one, we've got the other one.
And with stereo, we can build what's called a digital terrain model, the surface of Psyche, which we're very interested in knowing at a high resolution. Using the different filters, we actually can infer geochemistry of the surface. We can also associate it with the gamma ray and neutron spectrometry data set to sort of really drill down into the composition of the asteroid.
We'll also take pictures farther out into the infrared where the sensors are still sensitive and where we can get a little bit more information about the kinds of rocks and minerals on the surface. One of the other functions besides science for the cameras is that they are our navigation cameras as well. This technique that was invented back in the 70s called optical navigation. Take pictures of stars and star fields, kind of like looking at a sextant on a ship hundreds of years ago. The same process is used in modern space missions as well.
The instrument's actually being built by a company called Malin Space Science Systems. They built the LRO camera, they built Mastcam, they built Mastcam Z, they built numerous other cameras that have flown to Mars. And they do the final fabrication and quality control before then delivering that instrument to JPL.
No deep space camera system like this has ever been built. However, the components that go into the cameras all have a lot of experience in space, a lot of what NASA calls heritage.
When we get to Psyche, we'll go into orbit. The imager will primarily work during orbits A and B to get the images, to characterize the surface features, to make the topographic map, and to get the color images, which will hint at the composition.
Standard plan is that we're pointed straight down and we're snapping pictures as the asteroid rotates underneath them.
Usually the most important image that everybody gets excited is that first image that we acquire that you get back.
So the Psyche payload consists of 3 science instruments. One of them is what's called a gamma ray neutron spectrometer. It's actually 2 separate pieces of hardware. One is the gamma ray spectrometer and the other one is the neutron spectrometer. Both combined study the elemental composition of Psyche.
If you know the surface composition, what it's made of in terms of iron and nickel and silicon and oxygen, you can then start to say something about its history and how it formed and how it evolved.
By using gamma ray spectroscopy, we can measure those elements remotely. We don't have to touch the surface. We don't have to dig into the surface.
For Psyche, we're building kind of what we call the Cadillac. It's a very high precision, high sensitivity instrument. It's very similar to the Messenger instrument.
That technology that we developed for the Messenger spacecraft gave us a huge head start going to Psyche.
For our types of instruments, we don't get to fly them very often. So when we actually get selected for something, that's a big deal for us, where we can, take what we learned from the prior missions and implement it now and make an even better instrument.
Our instrument is kind of like a camera without a telephoto lens.
In order to get our best measurements, we need to be relatively close altitude above the surface. That's what we call orbit D.
So we can form maps, global maps, of the elemental composition of Psyche just by flying around externally.
You have galactic cosmic rays. That's a fancy word for very fast protons. They come in, they smack a planetary surface, they bust apart the atoms in that surface, all the neutrons rattle around, and as they rattle around, they end up producing gamma rays and neutrons that come out, and the gamma rays have energies, and they're like a fingerprint. So if you get the fingerprint of different energies that says, is iron there, is nickel there, is silicon, and then how many of those gamma rays tells you how much of that element is there.
And then we have a magnetometer, or MAG, that will measure the strength and direction of the magnetic field of the asteroid to determine if it has a remnant magnetization from its past core dynamo. Finally, we have a Deep Space Optical Communication System, or DSOC.
In our everyday lives on the ground, we use optical fibers for really high-speed communication, and that capability has been adapted for use in space near Earth. DSOC stands for Deep Space Optical Communications, which is using lasers to communicate at high rate. And the application of that to deep space beyond the moon is what the DSOC project is about.
Primary objective is to give future NASA missions the tools for returning data at much higher rates.
The signals travel at the speed of light, so they come just as fast as they do for the microwaves, but you could send more data in the same time of a pass for the same spacecraft resources. DSOC consists of a flight terminal that flies on the Psyche spacecraft, and then a ground network that has a station for transmitting up to the spacecraft and then receiving the laser signal down from the spacecraft.
Here we have to send a laser beam from Earth that the spacecraft has to receive, use as a pointing reference, and then initiate the communication link. So it's a very flight and ground joined at the hip kind of telecommunication system.
DSOC is being implemented as a technology demonstration to show that we know how to build terminals that can do this, with the idea that in the future they can be flown as part of the operational communication system on future missions. And we designed the terminal to operate out to about Mars' farthest distance. And Psyche on its cruise actually does a Mars flyby, so it's an excellent vehicle for the demonstration of deep space optical communication.
When and how is the mission expected to end? In this final phase, the mission team provides all remaining deliverables and safely decommissions the spaceflight systems. The mission is expected to end on 1st of November 2031 after completing its primary objectives and exhausting its fuel. The Psyche mission is more than just a scientific expedition. It is an adventure, a challenge, and a dream.
Psyche is actually a really cool mission, and it's actually a mission to a metal world.
And that made a bunch of us cry, to think that we could send something to investigate that speck of light.
We formed a really, really critical team, and it's really rewarding to see something that you've spent years on as part of a bigger system and a bigger mission.
So there is a sense where you're on pins and needles until you get that data back, and then there's the big relief, the big excitement, and then you get to work and trying to say, what does all this mean?
Graduate students 10 years, 20 years, 30 years from now will learn things about this asteroid that we can't even imagine today. It's the journey of a lifetime, and I didn't want to miss it.
Understanding how this universe works is kind of those first steps.
We can understand this universe that we live in. We can explore it, we can learn about it, and we can be a part of something which is much bigger than just us or just this planet. We will see new things when we visit a world made of metal.
Let's go discover things about our solar system that we have no other way to do. I think that it's fundamental to who we are and also who we should be. It's an incredible opportunity to be a part of the team making that happen.
We just can't wait to study it.
Oh my God, now we have to do it.